I'm going to start by expanding out a to show how this expression can be simplified. So because we have b to the power of 3 to the power of 5, this means we have b to the power of 3 multiplied by itself 5 times. And if we think back to the product law, because we have several powers with the same base of b, we can add the exponents to simplify. So 3 plus 3 plus 3 plus 3 plus 3 is 15. So b to the power of 15. A much quicker way to do this question is to use the power of power law, which essentially states if we have a base to the power of an exponent to the power of another exponent, we can multiply the two exponents together. So we could go b, 3 multiplied by 5 would give us that 15. So with b, we again have a base to an exponent to another exponent. So because of that, we can use the power of power law. So n to the power of 7 multiplied by 2. So n to the power of 14. When I'm using the power of power law, I sometimes like to put a multiplication sign between the two exponents to remind myself that I'm going to multiply them. For c, we can again use the power of power law. So we're going to be multiplying the exponent of 2 with the exponent of 3. So 2 multiplied by 3 becomes 4 to the power of 6, which is 4096. I'm going to first show d by expanding this out, and then after we can look at a shortcut. So x times y to the power of 4 means that we have this base of xy multiplied by itself 4 times. And when we put all this together, we have x times x times x times x, which is x to the power of 4. Y times y times y times y is y to the power of 4. So that would be fully simplified. A quicker way to do this question is to use the power of product law. So to do that, we basically take each of the factors inside the brackets and apply that exponent of 4 to it. So x to the power of 4 would give us this one. Y to the power of 4 would give us this one. So the exponent of 3 in this question needs to be applied to the 2, the m, and the n. So we would rewrite this as 2 to the power of 3, m to the power of 3, and n to the power of 3. And we would want to simplify 2 to the power of 3. 2 times 2 times 2 is 8. For f, that 2 outside the brackets will need to be applied to the negative 5. So negative 5 to the power of 2, and then x to the power of 2. And negative 5 to the power of 2 is negative 5 times negative 5, which is 25. G is a bit different than the previous questions because instead of being multiplied, the components inside the brackets are being divided. But a very similar thing happens in this case, a very similar thing happens in this question in that we have to apply that 4 to everything inside the brackets. So x to the power of 4, then 2 to the power of 4. And I will just rewrite this as 2 to the power of 4 is 16. So this here, instead of being called the power of product law, this is the power of quotient law. We can use this same law to help us with h. We'll have p to the power of 9, q to the power of 9, and I would say that's fully simplified, so we can just stop at that point.